Hey guys, welcome back. For this video, we're going to discuss lesson 4.5, which is arithmetic sequences. And yes, that is the way it's pronounced, arithmetic. Our goals here are to construct an arithmetic sequence and apply an arithmetic sequence formula. We'll do that last one if we have time. I'm going to try to keep the video really short because I want to show you how arithmetic sequences are related to linear functions or linear equations. So here we have some vocabulary. You might want to pause the video and write down some of these definitions, but sequence is a set of numbers that are ordered in a specific way. Term of a sequence is each particular number. So up here, 2, 5, 8, and 11, those are all different terms. You'll notice they're separated by commas. What makes this sequence arithmetic, what makes it arithmetic is to find the next term in the sequence, we're adding a constant value. So if you look at the one that's up there, we're adding 3 each time we go up to the next problem. So if I wanted to find the next one out here, I go to the previous one, which is 11, and I add 3 to it, and I get 14. And if you have this number right here, the same number every time, that's called a common difference. So that constant value we add in there is called a common difference. If you do not have a common difference, then what you're looking at may be a sequence, but it's not an arithmetic sequence. Now down here where it says nth term of a sequence or arithmetic sequence just means a particular term in the sequence. So if you look back at the top here, the number 2 is the first term, the 5 is the second term, the 8 is the third term, and the 11 is the fourth term. If I say find the 7th term, then the 7 is my nth term. We're just substituting this in with 7. So in this context is a parameter, it's a placeholder. So if I wanted to find the 7th term, I would have to go up to 5, 6, 7, and I'd have to add my 3, 1, 2, 3 more times. By the way, when we start here and we go one at a time, we call that a recursive method of finding our terms in a sequence, where we're adding 3, adding 3, adding 3. That same pattern over and over again is called recursion. Okay, so the first thing we want to do is be able to identify if we have an arithmetic sequence or not. And what I'm going to do is I'm going to take 14 and subtract 17, and I get minus 3. I'm going to take 10 and subtract 14, and I get minus 4. And as soon as I see that I get a different number there, so that's minus 3 and that's minus 4, if I had an arithmetic sequence, these numbers right here all have to be the same. In other words, I have to either subtract 3 every time or subtract 4 every time. So this one right here is not an arithmetic sequence. Okay, the next one we're going to find the next term in the sequence. This one says determine the next 3. So the first thing we have to figure out is what is the common difference. So we have to identify the common difference. Now another name for common difference is going to be slope. So the slope is going to be the difference here. So 7 minus 11 is negative 4. 3 minus 7 is negative 4. And negative 1 minus 3 is negative 4. Therefore my common difference is negative 4. Which means if I were to put this in slope-intercept form, my slope would be negative 4. So find the next 1, 2, 3 terms. We're just going to subtract 4 from this number, and that will give us negative 5. Then we're going to subtract 4 from this number, and that will give us negative 9. And then subtract 4 from this number, and that will give us negative 13. And this would be our sequence for the next 3 terms. Okay, for this next part, I'm going to show how these sequences are actually related to linear functions. The number 11 here is called the first term. The 7 is the second term, the 3 is the third term, and the negative 1 is the fourth term. Well, what I can do is I can actually create a table of values like this and call the top one my x values and the bottom one my y values. So remember, when we go from here to here, we get a negative 4. We call that the common difference, but in terms of slope-intercept, so y equals mx plus b, the m value, which is our slope, is actually going to be negative 4. The only thing that's missing from our problem is our b value, which is the y-intercept. And here's where general sequences are slightly different than linear functions. Our terms, or our sequence, begins with the first term and then proceeds to the second term. Our sequences do not begin with term 0. So since these are all x values, term 0 in theory, will end up being our y-intercept. So if I did want to create an equation for this in slope-intercept form, I would have to go backwards one more space to figure out what the y-intercept should be. But remember, when we do regular sequences, there is no term 0, so the y-intercept is ignored for term purposes. So anyway, if I go backwards one spot, instead of subtracting 4, I'm going to be adding 4, so my 0 term would be 15, which means my b value equals 15, and my equation would be y equals negative 4x plus 15. So how do we use this to find out our terms in the sequence? So I'm going to replace the y. I'm going to replace the y with f of x. So I'm going to put it in function form instead, plus 15. Now remember, I only showed the first 4 terms, but what if I want to find the 7th term? If I want to find the 7th term, so 7th term, well, x is my 7, so I'm going to find f of 7, and just substitute my 7 in place of x, and I'll end up with negative 28 plus 15, and f of 7, or my 7th term, will end up being negative 13. And we can figure that out by going back to the problem. We could put in 5th term, 6th term, 7th term, and figure them out. So subtract 4, I get negative 5. Subtract 4, I get negative 9. And if I subtract 4 again, I get to my 7th term. I'm at negative 13, and you'll see it matches this down here. Now that's how they're related to linear equations. Now there is another equation that also represents this, and it's called the traditional arithmetic sequence formula. And in order to do that, you need to know 2 things. You need to know the first term of the sequence, and you need to know the common difference. Now remember, common difference is the same thing as slope. So we already know that the common difference is negative 4. And the next thing I need to know is the first term. So the first term of the sequence was right here at 11. So my first term is 11. So how do I rearrange these into a new equation format that's still equal to a linear equation? Okay, so we'll go and write that out. So a sub n equals, this is actually the formula, a sub 1 plus n minus 1 times d, which is the common difference. So the only thing you're going to put into this formula is a1, a sub 1, and the common difference. And keep in mind that n here is just whatever term. So if I was finding the 7th term, like I did over on this side, then I put a 7 there and a 7 there, but I also have to fill in my parameters. Remember, these are parameters here. So the first term would have been 11 plus, and then in this case 7 minus 1, and then the common difference was negative 4, so I'm going to put negative 4 there. And I'm just finding the 7th term. So when you see it written like this, this says what is the 7th term. So that little subscript number is the term number you're looking for. If I calculate this whole right-hand side here, I end up with 11 plus 6 times negative 4, which will be 11 plus a negative 24. When I add those together, you'll see you'll get negative 13, which is exactly the same answer we got before. But if they ask you to just write the general equation, you would just write a sub n equals 11 plus n minus 1 times negative 4. That's the general equation, but I could still make it look like a linear equation by simply simplifying this problem. So I'm going to go ahead and simplify that to show you what it would look like, to show that it actually is slope-intercept in disguise. So the first thing you do is distribute your negative 4, and you end up with 11 plus, or 11 minus actually, 11 minus 4n, and then negative 4 times negative 1 is a plus 4. And then when I simplify these, I combine my 4 and my 1, you'll see that I end up with negative 4n plus 15, which this right here looks just like what we had up here. And the only difference is I'm now going to put a sub n down here. So instead of putting it in mx plus b format, this is just your arithmetic sequence format, but you'll notice that it's still slope-intercept. I got an m, an x, and a b value in the problem.